Here is our energetic speaker, Mr. S. Gopakumar, founder of Cape Electric and Obibo Betterman India. He is also the president and founding member of NFE. Until 2016, he was the managing director of Obibo Betterman. Currently, he is a shareholder of Obibo Betterman India. He has nearly 3 decades of experience in electrical safety. His main area of work is accident investigation and failure analysis. He is here to discuss about inspecting and testing of electrical installations. Why inspect and test? Because to ensure that places of work provide a safe, well-maintained electrical system. A simple way to provide this is to ensure that newly installed circuits and existing installations are tested on regular basis. So, to give a detailed insight of the topic, we would like to welcome you again, sir, and the stage is yours.
Sorry, we are actually running late, so I will quickly try to finish. This presentation originally was planned for 1.5 hours. Now I will try to squeeze it in half hour. One is gone.
45 minutes.
Yeah. No, because after that 15 minutes we have a presentation from the sponsors as well. That is also related to testing. So something, they will also take care. Okay. Yeah. So verification. First of all, we should understand that the wording which is used in the standard, not only in IS 732, almost all international standards, IEC standards are verification and it's not audit. Because audit is a process which we do on sampling basis. If you have 100 circuits, we do probably 10 on selective basis or maybe 5. That is audit. Whereas verification is a process which is nothing but a thorough check. Each and every part has to be checked. That is verification. Verification includes inspection and testing. You need to do both inspection and testing. I will try to explain you some informative or some information on verification. Basically, in a typical industrial scenario or in a larger building, you have the high voltage installation, something like this. One moment. Yeah. You have the high voltage installation. Basically, the high voltage installation is confirming the safety measures shall be as per IEC 61936, which is already adopted as an IS standard. I don't remember the number exactly. The low voltage installation basically is as per IS 732. Sorry, I didn't mention the NEC. Yes, of course, NEC 2023. So, the high voltage there is a safety measure, low voltage there is a safety measure. Now, these two are at the top. These two are the installation standards. They talk about how the whole installation looks like. On this installation, we are going to have machines or equipment or lift or the connected current using equipment. Now, each of these current using equipment has got its own performance requirement, its own standards. For example, IEC 60201 for low voltage machine, 60204 part 11 for high voltage machine. Lift ISO 8100 for your information, we were, lift is a very much integral part of our MEP. A new standard has been published 3 months back. Now the ISO has been adopted as an Indian standard. The number actually I don't have much information on that, but of course there is a standard. Then I am just explaining you some of the examples. IEC 630443, this is a automation system. So if we look at this particular list, this list is very long. Each of the product standard, for example, panel boards. Yes, after installation of the panel board, after making the termination, the panel board has to be tested properly. And those test requirements or verification requirements are explained in the product standard. So basically there is an installation standard, there is a product standard. Once when you do a verification of a new installation, you have to comply both the installation standard and the verification points of the product standard has to be made. I have also made the last one, 61052 EMC, electromagnetic compatibility. Somebody spoke about the EMC compatibility. Of course, if you have a lot of electronics in your installation, EMC compatibility is also necessary. EMC compatibility, there is a specific subject which ensures that the harmonics or noises are not creating disturbances to your electronics, and all the electronics are functioning properly. So it is not only about one subject, it's a group of so many subjects. I just show you the testing part of 60201, which is a low voltage machine. This class number 18.1, you can see here in all the product standard, this is not about installation, the product standard, the first part will be checking the compliance, whether this product is in compliance with its own test requirement, whether it is tested, whether it is complying to the product standard. That is the verification number 1. Verification number 2 always is verification of continuity of the protective bonding circuit. That means this machine has got a earth terminal, you have an earth equipotential bonding in your installation, and you are making a wire connection between these two. From between these two terminals, you should measure the resistance and ensure that it is lesser than the allowed limit. Let's say, for example, you are using a 6 square millimeters wire and 5 meters, then the resistance of the wire, including the termination, shall be lesser than whatever in the calculation coming. The second test always, in case of fault protection by automatic disconnection of supply, condition of protection by automatic disconnection shall be verified according to 18.2. As I said, automatic disconnection of supply, it has got some meaning. Yesterday I explained the automatic disconnection is the general term, but if you look at the definition of automatic disconnection of supply, it contains basic protection, basic protection by insulation or enclosure, then automatic disconnection by protective equipotential bonding, and automatic disconnection of supply. This line, the second line, the line C, it consists of the whole thing. Conditions of protection by automatic disconnection as per this 18.2, then insulation resistance test, voltage test, protection against residual voltage. These are, I'm just trying to explain or show you some examples. Always, the most important two tests are continuity resistance test of the protective conductor and fault loop impedance, or the conditions of automatic disconnection, because in case of any fault in this machine, the protective devices should trip. That is the idea. I am showing you, okay, let me skip this. This is about the detailed test, not important. Lift standard ISO 8100. The first check is visual check. Yes, of course, find out, the physically any degradations are there, whether the wires and connections are intact. And the first test is continuity of protective conductors according to IEC, for example, IS 732 part 4.2. So continuity resistance is the first test, measurement of the insulation resistance is the second test, verification of the effectiveness of the measures for fault protection, protection against indirect contact by automatic disconnection of supply. So in this third, the serial number D, it is not simply automatic disconnection of supply. This is fault protection by automatic disconnection of supply. Verification of the effectiveness of the measures for fault protection. That means you don't need to check the basic protective measures, fault protective measures by automatic disconnection of supply according to this particular clause. Whatever the machine which you take, always these two are the most important test. But practically making this test, I don't think that this practice exists in India. Have you saw this kind of a test carried out? Yes, of course. For example, Schindler, lift. Wherever Schindler goes, there is a fight between Schindler and the owner of the building, because they do this test and they say that my test failed. I have so many cases. The test failed. Then they simply ask, my machine is having a 3-phase drive. Lift is having a 3-phase drive. I need a type B RCD for fault protection. And this type B RCD for his rating is not available in the market. So then the fight starts. I placed order for 20 lakh rupees and this guy is asking something, some small thing which is 50,000 rupees, and and my inspector is coming tomorrow morning to inspect and this item is not available in the market. All these fight starts. The very simple method to handle this situation is, if you have a TNS network, properly designed, installed TNS network, the test is passed. With a simple MCB, the problem is solved. So this is how it is. Now, before making the testing, you should also understand what is a type 1 equipment, type 2 equipment, or class 1, class 2, class 3 equipment, which I explained yesterday. Now, you also should understand what is meant by fault loop impedance. I am showing you two pages or 2 clauses from the IS 3043. As I said, fault loop impedance, which is the most important safety measure finally when it comes to the testing. I also told about 33, 34 places it is explained in IS 3043. 40 years, last 40 years, even today we don't do. Now this is, you must understand what exactly and how exactly this is handled and how to maintain the fault loop impedance to a level which is lesser than the allowable. First of all, we also should, all of us should think that the idea of fire due to short circuit, fire due to overload, or fire due to poor quality wire, actually this is not, these are wrong. The reason is you have a protective device and the protective device is not working. So the protective, due to the non-operation of the protective device, fire or accident happens, or either the protective measure is not available or the protective device is not operating. This is the problem. You have to understand the tripping curve of the device, you have to find out, you have to have certain calculations. Now in the NEC part 1 section 18, we have included this table, the type of MCB and the required fault loop impedance. Now, if you look at here, ZS into IA is less than U0. This is actually called as a calculated value. The one which is at the bottom, ZS equals 2/3 of U0 by IA. This is the measured value. The value which we are supposed to achieve is 2/3 of the calculated value. So you may be able to work with 1 ohm, but practically we are supposed to achieve 2/3 of the value. If you look at the certification process, finally somebody is designing, somebody is erecting, and another person is going to do the verification. There is 3 parties are involved. So the system which is followed in Europe, or the system which is considered in IEC 60364 is, for larger installation, all the 3 parties must sign this particular certificate. All the 3 people should sign the certificate. Then only in Europe and all you will get insurance. Otherwise there is no insurance or there is no coverage, and practically you will be in trouble. The national authority decide the size of the building with which single party can approve, 2 party can approve, or 3 party can approve. It is also, the clauses are also made in such a way that the responsibility of one person is not crossing the responsibility of the other person. For example, the designer has designed or decided the size of the wire and he has made the cable schedule. The inspector need not have to check whether the cable sizes are appropriate or not. That is not inspector's job. Inspector has to open the panel board and he has to check whether the cables used are correctly as per the schedule. So inspector need not have to put the head into the responsibility of the designer. So like this, inter-competition or clauses are made in such a way that no one is fighting each other after some time. Inspection shall be done prior to energization. Of course, prior to energization in the case, some of the inspection, not the testing, inspection has to be completed before energization, and it shall comply to all the safety requirements of the standard. If you say, or when we say all the safety requirements, once when you see the list, then you will be able to understand what are the safety requirements required. initial verification, if you are doing for the first time, the results shall be recorded in the annexure QQ and RR of IS 732. Of course, my slide is a little bit late. An improved format has been included in NEC Part 1 Section 17. You can follow that particular format. But please note that these formats are only for, just to inform you that these are the informations required. You can apply it for a house or a small residential application. You cannot use these formats for a large industry. If you go and use this format, you can take the information, okay, these are the informations required to make a verification, but if you try to, or tomorrow if the electrical inspector or somebody asks, I want the test report only as per this format, actually we will be in trouble. For larger installation, we have to modify it, we have to make it much bigger. So then, test results shall be compared with the data. For example, just somebody should verify, or the inspector should verify, I have the data, now I have the cable schedule, or I have the switchgear drawings, and he has to compare and compile the data, and finally he has to certify it, and in case of any defects, he has to inform the designer and the contractor, and they have to rectify. Actually, it is made in a systematic way. And this is followed, the same systematic way is followed all over Europe and America, plus nations like Singapore or South Korea, Japan, all the developed nations, they follow the same system. What I wanted to tell you is it is not a standard for India, this is followed globally. If you can excel in this work, there is a big opportunity, there is a big scope, there is a huge manpower shortage in developed nations to do this particular job. It's very easy to get, employment outside. The formats are given. Inspection. I don't want to explain all the inspection parameters. There are about 18 inspection points, inspection in the sense physical checkup, visual checkup. There are 18 visual checkup of either of the installation or the drawings or the documents or the sometimes the test certificates. So there are 18 points, plus I have put one more, the 19th one. It is not a safety subject, but it is a reliability subject, which is more related to EMI/EMC or the functionality of your equipment. Especially point number 19 is related not exactly to functionality, it is related to EMI/EMC. Functionality, something else also comes into picture. Now, the first one, method of protection against electric shock. This blue 4.2 means it is as per the clause 4.2 of IS 732. The same wordings are also repeated in the NEC, because to make it, to avoid confusion, NEC also follows the same clause number 4.2. Now, as I shown yesterday, protection against electric shock, basic protection, fault protection. Basic protection has got basic insulation, then enclosures, barriers, placing out of reach. Then the fault protection consists of double insulation, sometime automatic disconnection. So many measures are there. So you must, the person who is doing inspection, he must do the inspection based on the location and based on the adopted safety measure for that particular location. For example, solar, rooftop solar, PV, DC side, it's double insulation. In a normal industrial or residential purpose, it is automatic disconnection. So the person who is doing it, he has to have good knowledge about the particular system, and then he has to do the verification or inspection. Number 2, presence of fire barriers and other precautions against propagation of fire and protection against thermal effect. Actually, in this one line, there are 3 subjects. Presence of fire barrier. So first, the fire or somebody who is designing the fire protection system, they have to specify the areas where fire protection is required. So somebody has to categorize, okay, this is a place where fire shall not pass to, and that area the electrical engineer or mechanical engineer is going to put or apply the fire sealant. Now the fire sealant, once when you apply, what is required is, for example, as per the clause numbers of, you can read these clause number probably later, what you have to do is, or what the person should do is, he has to check first the test reports of the manufacturer. Under what condition this material is tested? What are the accessories which is used during the test? Whether these accessories are used by the contractor in this particular installation, whether all the conditions of tests are met in this particular installation. For example, you are using some sealant which need 100 millimeter, and if the contractor applied only 90 millimeter thickness, then the integrity is gone. So all these measures need to be physically verified. So like this, starting with this, there are 19 points. So if we quantify this job will be, the volume of the job will be almost half the volume of the work done by an electrical contractor. In a typical project, if electrical contractor, his labor is, let's say, 10 lakh rupees to do this verification, testing and inspection, the cost, the manpower required, the amount of, the cost involved will be almost half of that. Please keep this in mind. There are 10 tests included. The first test is, of course, the continuity resistance measurement of conductors and comparison. And if you look at the standard must have written continuity resistance. Actually, I fight in the standard to change to resistance measurement, because continuity resistance in India is always, you take a multimeter and put it on both sides, the multimeter makes a sound, beep, 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 then continuity is there. This continuity resistance is not about, listening to the beep. This continuity is about measuring the resistance of the conductor. Then the standard gives you a table. So you must check whether the resistance of the conductor is within the limit of the table. And now if you look at this table, the most important point, the resistance given is of class 2 copper wire. Class 2 copper wire, I don't know, probably somebody from Polycab, I need your help. So once when the NEC is implemented as a mandatory requirement, to pass this test, class 5 copper wire is required in the final circuits and in the protective conductors. Now, how many percentage of class 5 and class 2 wires are sold in the market? Any idea?
Yeah, now at this moment,
yeah, you can tell me, I will repeat.
at this moment, we are like, all over India, class 5 conductor is very popular. And mostly, Phenolics started this product and...
No, please don't use anybody's name.
Okay. No, I'm telling the history. It is not the...
No, just a simple question. Out of 100 meters of cable...
80% people are using, 80 and 90% people are using class 5 conductor.
Yeah, please note there are two type of flexible wires, class 5 copper, class 2 copper. Class 2 copper is having lesser resistance. I don't know how many percentage.
Class 5 copper is lesser resistance. Class 2 copper is higher resistance.
No.
But class 5 is used because in this conduit wiring, it will be very, very easier. Class 2 will be difficult.
No, class 2 is having a lesser resistance. Class 5 is having a higher resistance.
Yeah, that is true. Class 2 is lesser resistance, class 5 is higher resistance.
Yes. Now,
so current carrying capacity is better in class 2. Current carrying capacity is poorer in class
5. So, yeah. Now, class 2 is having a lesser resistance means, maybe the size of the copper is more or something is more. As a result, cost is also more. So probably 5-6% or 10% higher. So as he said, about 90% of the wires sold in the market are class 5, which is having, let's say, 10% more resistance. Now, once when the NEC becomes mandatory based on the CE regulation, the first non-compliance which the electrical inspector is going to put on your project is, there will be one tick list, what kind of wire you are using, class 5, that's all. No, so this will be one non-compliance, please.
One point is there, below 16 square mm class 2, above 16 square mm you can go for the class 5. So that possibility is there in the NEC.
No, that is okay. We are here, the resistance measurement, it is not for all the wires, it is for the final circuits. The final circuits and protective conductors. So now actually from BIS side, this NEC is, you know very well, NEC is becoming popular, and electrical inspectorates also started asking the question, for installations where class 5 copper wire is used, what do we do? So we tell them that you consider probably 20% derating for the existing installation. We cannot do anything. But at least in the future installation, if somebody is coming with the class 5, you reject it. Because it is not as per, it is a non-compliance. You reject it. At least after 2 projects, they will change to class 2 conductor. So please take care of this in your design. You must write that any copper wire which you are using must, in a conduit wiring, must be of class 2 copper. You must write it. Otherwise, after 6 months, once when your project go for approval, you get a shock. Just because of copper wire, the project is, or the wiring is, the inspector, now you know how sometimes they ask, they say, no problem, you replace the whole wire. So don't get surprises, it will be too pain. So take care of it. This 10 testing, it starts with insulation resistance of extra low voltage system, floor and wall impedance and resistance, polarity test, effectiveness of automatic disconnection of supply. Now out of these 10 tests, what we should understand is 4 tests are carried out in supply off condition and 6 tests are carried out in supply on condition. Let us look at test number 6, effectiveness of automatic disconnection of supply. Tomorrow, once after 6 months, once when you go for the approval, inspector will ask, you do a small test in your facility and give me the report. Now, at the moment they may be asking, show me the earth pit. They may not ask this question. They may ask, okay, show me the test result. And at that time, in your design, if you didn't take care of it, I am sure that the test will fail, and this is going to be another red seal into the approval. Be careful. So these are the tests. Now in the NEC, we have included one more test, which is called as PAT, Portable Appliance Test. Now, the idea of these 10 tests are to ensure that your installation is in very good condition. So you have a very good installation. Now, if somebody comes with a faulty equipment and connect the faulty equipment into a good installation, there can be an accident. In order to avoid installation or plugging of a faulty equipment, the 11th test is included, which is called as PAT. Sorry, it is missing in my presentation. Portable Appliance Test. There is an equipment, there is probably Shyam will be able to show you some picture in the next presentation. What is important for the inspector is you should keep the sequence of this test. Don't try to do first test, go to the 9th one, then come back to the 2nd one. That is not allowed. You should keep the sequence. And in case of failure in a test, you should inform the appropriate people. They should rectify it. And then you have to restart from the previous test onwards. Not from that test, from the previous test onwards. Then potentially, if you have explosive areas, that is special. So basically, inspection and testing, both are important. It is not only about testing, it is not only about inspection. It's a combination of both, not only the installation, but all the connected equipment as well.
One question.
As I said, yeah. Yes, please.
Any minimum size NEC is recommended for this installation? Means let us say house wiring. So any minimum sizes to be adopted?
Yes, it is there. I think 1.5 square mm.
1.5. So, okay.
It is there. Can you use them?
Class 2. When there is a condition to use only class 2, then where is the question comes for the production of class 5?
Yeah, class 5 is a wire which is for short length and appliances. Appliances means you have a TV and from the TV to the plug. It's a highly flexible cable. For appliances you can use it. Also I think for panel board wiring you can use class 5.
Then the manufacturer should be informed to the government. If it comes, then there is no question from the consumers. There is no problem from the consumers.
Correct.
The consumer awareness is not there. Okay.
Correct.
Manufacturer awareness will be there. So manufacturer they can say that this cannot be used. Only class 2 will be supplied in the market.
Gopa, can I just answer?
Yes, please.
Yeah, I just like to answer this. See, actually what has happened is BIS in the, in the IS 694, earlier it was very different. The definition was very clear, end use application, class 2 and class 5. There was an amendment in 2009-10 which it led to a general interpretation where the end use was not mentioned. So class 2 was being replaced by class 5, and that gave rise, some of the manufacturers have started supplying class 5. Class 5, ideally it is only for panel wiring. So because of this loose interpretation, and of course there is a commercial benefit also that is added on to that. So class 5 was being used, but this NEC effectively plugs that loophole. So henceforth, there is a representation with the BIS also, because 694 has not been touched for a very long time. And even regulatory authorities, they do not want to make any amendments. But now they are willing to do it. The amendment will come only by specifying the end use. So which means fixed wiring, class 2, flexible for panel wiring, class 5.
So now the question, I hope it's answered, sir. Why this is, anyway, whatever damage happened is happened. We have to, at some point of time, we have to correct. This is the correction. Now there is no chance of a loophole. Actually, okay, just for a joke, IS 732 was published in 2019. This table was included in IS 732 as well. But once when the printed version came, this table was, the table disappeared. So this was actually a surprise to me. Where is the table? Most important, it disappeared. But then we cannot talk. So in NEC, until the last moment of the printing, I was chasing this. Weekly once I was calling, what happened? This table is there or not? So the printing department, they were telling that so far no one from the technical committee used to chase like this. Why are you asking? Okay.
But if you see this 1956 Indian electrical rule, many article or many clauses come into the IS 732. And there are some missing over there, and then also it is missing over there. NEC has done a good job, and that class 5, class 2, that is they are clearly written what circuit to be used for which wire. So that is also given.
Okay, thank you. So now let us continue. So whatever I was explaining is for the normal installation. Now in our building we have a special installation which need additional verification. Special installation means example bathroom or office rooms, hospitals, medical locations, group 0, group 1, group 2, medical locations. These locations need additional safety measures or additional verification points. Now once when you, in a hospital location, once when you do the additional verification, the person who is doing also should be aware of the standard which I told just now. The hospital, for example, MRI. MRI has got its own requirement. For example, last week I was in a hospital and the MRI company, they were saying, I want a separate earth. Then I asked, okay, you show me your manual. Then he started showing his manual. In the manual, very clearly written, the maximum allowed loop for this is 0.29 ohm. Then I asked, if you put a separate earth bit, your loop will be much more than 2 ohms, 3 ohms, and you are technically disqualifying your equipment. Then we went to a site where he already installed, measured it, it failed. Then there was a, the box is open. Then finally, after 2 days, I could tell him that what you are doing is wrong and you should not do it. The subject is taken up to their management. Now they are correcting. Actually, the problem is correcting each and every such manufacturers. It's a tough job. So these additional verifications are required. So now class 2, class 5, you know very well. We had a good discussion. With this, I stop. Thank you very much. No, we have...
I have one question.
Yes, please.
This you have shown this wiring installation. So any clarity on wiring installation based on hazardous location? because many people are buying normal product, normal cables, normal wire, and they use in the solvent atmosphere, maybe coastal atmosphere, and then maybe within 1 or 2 years it's spoiled and short circuit.
No, that is what Mr. Krish explained. You have to select the cable and install it according to the environment.
So
those selections are already there.
Classification we have not seen this one.
Cable classification is not the job
location
of...
classification.
Yeah.
Like hazardous level 1, hazardous level 2, 3, or class 1, class 2 like
Krish,
this.
you can use this mic.
Yeah, so if you look at the pages in 732 and NEC, just before they get into the wiring installations, there is an entire table that classifies external influences based on the grade of external influences. If you want, I can meet you during the lunch break. I've got the regulation with me and I'll show you the table.
Sure, okay.
Thanks.